everybody that's joined. If you've never joined one of our detection dispatches before, my name is Jeanette, and this is our bi-weekly live series where we do a handful of workshops, Q&As, hands-on lab experiences to help the detection engineering community connect and just to level up their skills together. Today, I'm joined with Kevin Zook, and he's going to be doing an awesome session on all things Webshell. But without further ado, I'm going to pass it over to Kevin, let him kick off the session.
I'm Kevin Zook, threat hunting engineer at Anvilogic, which basically means I help develop some of our hunting related products. And I also do hunting for our customers. They've signed up for it. So I look through customer data as well. The goals of this are basically to familiarize you with web shells, how they work, how to find them, where to find them. And I want to give you an idea of how you would go through an actual investigation, some lab data that I made to hopefully prepare you to find it in a corporate environment. And hopefully from this, you gain practical experience through the lab we put together. So what is a web shell? They're scripts uploaded by an attacker to a web server, a victim web server that allows access to the system in an improved way. Like, for example, to execute operating system commands or browse the file system and download and upload files, that type of thing. Anything that the web server's normal functionality wouldn't typically allow through the applications that are on it. Vast majority of the time, web shells have an extension appropriate for the server that they're on. So if you're running a PHP-based web server, then there'll be PHP files most of the time. If you're running IS, you'll have ASP.NET files if it's enabled on there. At a minimum, a web shell will typically allow either command execution or file browsing, but there's no reason it can't allow both or both and more, depending on what the goal of the attacker is and the goal of the person that wrote the web shell, what they want it to be used for. They can be deployed in both Windows and Linux environments. And once they get on a web server, the impact tends to be very, very similar just because of how web shells work once they're actually on a victim's machine. There is automated web shell deployment, but it tends to be kind of just like blasted out to everywhere type scripts that do that. And they tend to be lower on the seriousness scale of an attack. They're more often deployed manually by the person that, plans on using it right after. And they can find that through a bunch of different ways that I'll talk about later. Web shell operation pretty much has to be done by a human because you have to think about what you're looking at as far as the file system and try to probe through different ways of getting on the system. Like there might be permissions on an account that doesn't let you do something exactly the way you want to, and you kind of have to improvise a little bit as an attacker. That's why web shell operation is it's limited to human activity for the most part. So there's a lot of reasons why a web shell would be attractive to an attacker. First is that web servers, they're always online for the most part. They're always available. So any vulnerable scripts that are on there are very attractive to an attacker because they can reach at any time of the day. And it's quite hard to detect. A lot of places will have web shells for a while and not know, and then you'll come along and find out that it's been there for a while. That's a very common scenario. It's a common vector for targeted attacks. So if you've heard of attacks in the news, a lot of them came from a web shell. Not to say that all the big breaches are from web shells, but a lot of them are. And there's no reason why you can't try to compromise web servers at the same time you're, spear phishing people. So most attackers will at least try this angle just to see what they can find. Most attackers use web shells to gain initial access to an environment. So once you're on the network of the web server, depending on how well it's separated from the victim themselves, like their corporate network, that's going to be the level of access you get. So if it's just a corporate network that has a web server also on it and it gets compromised, congratulations, you've let in an attacker if they compromise the web server to your actual AD network. Most of the time, attackers will try to move on from web shells fairly quickly. They'll just get on there through a vulnerability and then they'll deploy something more substantive that allows them to, customize what they're doing better or do what they want faster through software that they're familiar with. So they'll try to deploy backdoors and more importantly, move laterally. So the move laterally part is what makes isolating web servers especially important. what you want is to have these web servers in a DMZ. So if the DMZ is compromised, then the attacker only has access to other machines in the DMZ instead of the entire corporate network. And while it's possible to carry out an entire breach using web shells, it's typically just not practical, just because backdoors and other utilities that run at the OS on the OS normally, they're a lot more predictable than web shells, and they're usually a lot more privileged and powerful. Okay, so web shells are deployed a couple ways. They have to land on disk for the most part, although I've seen some attackers try to do a lot through a vulnerability itself, but the incentives for doing so are kind of low, just because web shells are more predictable than executing a vulnerability over and over. So exploits are common to get the web shell on disk. It can be targeted at vulnerable software that's running on the web server, like Struts, Cold Fusion, Move It. There's a lot of different web server vulnerabilities out there. Another way is implementation flaw. So if somebody does something that causes the server to allow it to later be compromised, like, implementing a upload script that's supposed to be for images, but not checking if it's an image, for example, can definitely get a web shell on your server, especially if you don't do anything to prevent it from executing after it lands on disk after. That's a very common scenario for a web shell. If FTP or SSH credentials get compromised and it has access to the web directories, an attacker could simply just plop the script on there and start using it. But this scenario is a little bit less likely, I'd say. Okay, so there's two types of web shells when it comes to how commands are sent to them. There's get and post, which corresponds to get and post methods in HTTP. They behave differently in how they're relayed, which I'll show you, and they appear differently in web server logs. Get shells are usually better to have if you're the one conducting the investigation, just because more of the bad stuff that happens when a get shell is used show up in logs than for a post shell. And the big reason for this is the URI query field that show up in logs. Get shells will relay commands in get variables, which will show in the URI query field, but post won't. Post only shows up in post variables, which don't show up in web server logs for the most part. They might show up in error logs, but in standard web logs, they don't. If you have full PCAP, this is basically mitigated because you can see all the post variables in a full PCAP as well as the get variables. So in addition to the way commands are relayed to the web shell, web shells can have different visual styles. They can be password protected. They can be completely encrypted. Some of them talk to databases. Some of them have functionality to clean themselves up. It really depends on what the web shell is meant to do. So here's some examples of get shells. Like I said, they're simpler, provide more evidence in web server logs. They relay command contents through get variables, which are in the URI query field, which if you're looking at this presentation, the URI query field is basically the question mark and everything after. See how it says CMD equals who am I? In this case, that basically means whatever is after the command equals is the command to be executed at the operating system level. So given that it's in the URI query, we can basically surmise that this is a get web shell. And if you saw this in a log, it would also have get instead of post. Same deal here, just with another layer of obfuscation. This is basically just base 64. The idea behind this would be basically decode it and then execute it. In this case, we have kind of directory browsing. I actually took this example from one of the lab shells that I used. In this case, there's an action equals and a dir equals. So the action is list dir and the directory is var www. So if you saw this, you could assume that whoever is using it is trying to navigate a Linux file system, specifically weblog. So URI encoding is very common in web requests and logs, and you'll need to probably URI decode some stuff in the lab using CyberChef in order to read it easily. So that's something to keep in mind. So post shells are much more annoying to deal with. Their operation is a lot less obvious. For example, you may have an attacker that's used a post shell to execute 30 different commands on the victim machine, but none of those actual command contents will show up in the logs simply because post variables are not typically in web logs. They're just part of the request. Again, if you have PCAP, you won't have to worry about this, but for logs, you will. You're mostly going to have less satisfying answers to the questions that people are going to ask you if it's a post shell, just because you'll be able to say things like when the attacker showed up, how often they used the shell during what times, and maybe how large some of those sessions were, but that's it. You're not going to have all of the commands. You're not going to have everything they browse. Now, if they use a post shell and then browse to it after the fact, you will see it. But trust me when I say that it's a lot harder. Like I said before, commands are relayed to post shells using post variables. Post contents can show up in error log. You're going to have to rely on fields like bytes transferred if available. And in the lab, you don't have bytes transferred, which is very annoying, but you do have time taken. So you're going to have to rely on that a little bit more than you would, especially if it were a get shell. Timing, more important with post shells as well, simply because you don't really have anything else. Here's some ways you can defend against web shells, I guess, before a server is compromised. Isolating all of your web servers into a DMZ environment is pretty important because it'll just limit the exposure. Limiting the access of the user running the web server to only exactly what they need will make life harder for an attacker, because if you have it running as like root or whatever, it's going to be very easy for them to do whatever they want. Whereas if you run something that's more locked down, then it'll be harder. So if you have any solutions that can report on new files that show up on the web server or show up for the web server's logs, that would be useful, but it's kind of hard to triage that stuff just because the nature of some web applications, they'll have new files on them regularly, and you'll just have to go through and prove that they aren't malicious, which takes a lot of time. So if you're able to decode SSL and generate PCAP, that's kind of the best case scenario, just because it won't matter what type of shell it is and you'll have full visibility, but it's very expensive and very few places have it. So the most common types of web servers I see get compromised by web shells are usually Apache and IIS. Apache more common for Linux environments, where IIS runs on Windows, all the Windows Server operating systems. Both of those have different default settings, and even in different environments, the standard of what is normal might be different. Settings tend to be cranked up if you're working with a place that has been compromised before, just because that's a common ask during remediation to bump up logging. You'll want to know what fields are available as soon as you get the logs. And after you've worked through like 5 or 10 of these, you'll know what to look for, like which fields are the best. URI query is really important for finding get shells. URI path is very important for seeing what files the attacker was interacting with. Bytes transferred is very important to see how much of it they were doing in one session, it being whatever you can tell. But bytes transferred is going to show you how many bytes went over the wire, which is kind of important. And a kind of lesser indicator is time taken. The longer the time taken for something, the more likely it is that they had a substantial session. And when a person tends to be using a web shell, it'll tend to fluctuate rapidly. So like they'll have a couple hundred seconds or a couple hundred milliseconds time taken, and then they'll have way more depending on what they're doing. It's important to ascertain early on whether the web server is part of the corporate network or isolated, just because the severity is going to be totally different and what you're going to ask people to do is different. If it's part of the corporate network, you're really going to want to cut off the server from having access to the AD environment or the corporate network as soon as possible, with the understanding that if you take it off, the web application that it's running is going to stop. So there's going to be business impact. But I would say like 99% of the time, the web shell is worse than the business impact of taking down the web application. But you definitely have to ask and work with the server admins. If it is isolated, it makes things a little bit easier. You're still going to want to focus on lateral movement, but the lateral movement is going to be limited to other things in the network that it's connected to, which is going to be less if it's not the corporate network. Here's some telltale signs of web shells. The first thing you want to know is if you put any server on the internet, if you expose any web application to the internet, it's immediately going to get slammed by all sorts of things: scanners, search engines, actual users. There's just going to be a ton of it, and it's going to be constant. So if you see a lot of traffic to a web server, doesn't necessarily mean anything. That's kind of just a symptom of having a server on the internet. The important part is to distinguish between the noise and the actual bad stuff, which I'll talk a bit more about. So as far as telltale signs go, if a new file shows up on a web server and only one IP is accessing it, that's fairly easy to contain and analyze. You'd want to get a copy of the file to see what it's doing or what it can do. If it's malicious, obviously you can block the IP that's doing it and take the file down, but you'll want to figure out how it got on the server in the first place as well. If numerous IPs access the same file around the same time, some attackers will work like this, where they'll have like a revolving proxy or something like that, or even multiple machines that they do bad stuff from, but they'll never actually interface with the web application itself, just because they know where their shell is, they know what they're working on, and they have no need to interact with the actual web application. It's also worth saying that there's some attackers will interact with it, especially in the early stages, to find an exploit or something like that. If an IP shows up in error logs with code that appears to be a web shell or have nothing at all to do with the application, that's when you should be really worried. Try to figure out what IP is generating the error logs, and look for that activity in the actual logs to see what they successfully did. A lot of the times when you do that, you'll realize that the files that they're interacting with on the server are also malicious, in addition to the stuff that shows up in the error logs. So if OS command contents show up in GET requests, that's a telltale sign that they're at the very least trying to execute commands, but depending on who's doing it is how severe it is. So if there's just a scanner out there that got to your IP because it scans all of them, and it's making GET requests for bad looking stuff and stuff that has command contents in it, but the server responds with a 300 or 400, chances are that they are not successful in what they're doing. They may be trying, but it's not successful. And with a lot of scanning stuff, you'll see 50, 400 codes in a row. That's a telltale sign that it's a scanner that doesn't really know what it's looking for. The more surgical something is in looking for stuff on the server, the more you should be worried. So if you ever have command contents that build on each other, like, for example, somebody pings an IP address and then uses a PowerShell script to then try to go download it, it's safe to say that that's much more severe than somebody, for example, running, hostname, who am I, and then dir, and then they go away. Like, they don't interact with any files at all. They don't show any knowledge of the file system at all. Chances are they're not that serious. But if somebody is successfully executing commands that build on each other and they're not getting those 300 or 400 codes, that's something to worry about. Another way people find out about web shells is they'll see, like, for example, W3WP, which is the IIS server process, spinning up like cmd.exe or PowerShell.exe. It really shouldn't be doing that. And if it does, it mostly points to the fact that somebody has gotten the web server to do something that it shouldn't have been doing. And one of the chief ways of doing that is web shells. So it's a really useful indicator when a web server is doing something like that. And you should be very worried if you see a web server, trying to download a file from a remote location or anything like that. So sometimes an attacker will find a implementation flaw that involves like uploads, like if there's an image directory and you don't check to see when you're uploading if it's an image or not, or you're not even checking to see that it's not a script, stuff like that. You're not doing any input validation. The less input validation you have, the more likely you're going to run into somebody putting a web shell in a place that you didn't expect it. So you definitely want to have your developers make sure that they are only allowing what is expected to be uploaded to a web server that's internet facing. Let's quickly go through HTTP status codes. Let's start from the 500s first. So if you have 500s, it usually means that there's something very wrong on the server's end, and it's not necessarily your fault. Like if a reverse proxy goes down or something like that, you'll see 500s. Or if there's some kind of configuration error on the server, you'll sometimes see that. 400s basically means it didn't work. Most common, obviously, is 404. And you'll see that when, for example, like a file scanning script tries to go to a file on a web server that doesn't exist, you'll get a they'll get a 404. 300s is redirection, and you'll have to look into that more usually. Sometimes a web server will always redirect instead of give 400 levels. I don't know exactly why that is, but it's certainly out there. So maybe partially successful, depending on what it's supposed to be doing. For 200s, this one's kind of, sometimes people don't understand exactly what it means. 200s mean that the transaction was successful from the perspective of HTTP. It does not mean that everything went the way that you think it did with regards to the script engine, any of that stuff. It simply means from HTTP's perspective that it worked. So it's possible, very possible, to have a 200 code on an actual web shell that didn't work. And those cases are kind of hard to identify when that happened. But for the most part, when you see 200 in web shells involved, you should be worried at the very least, and it's worthy of more investigation. So I covered a little bit of this earlier, but I'll go over a few more things real quick. You want to check what a machine has access to, because that's going to inform your response. If it's on the regular corporate network, that's definitely not good. If you ever have an admin tell you that there is a jump box, that means that if the attacker accesses the same junk box the same way, they will have access to the same thing that the people that use the jump box use it for. So if there's a jump box out there that allows an admin to go from the corporate network to the DMZ to upload stuff, it usually follows that they can go through the same way. Not always, but sometimes. So you want to get all the details on what the DMZ actually is every time, because it can wind up burning you. You can often ask an admin to remove the network cable from the back of the server, which will, put a Band-Aid on the problem, but you'll still want to investigate. And if the attacker tried pivoting when you pull the cable, you'll basically kick them out. But if you have similar applications running that are still exposed to the internet, there's no reason they couldn't come through there. So it's not a perfect solution. It's just a temporary slow them down type thing most of the time, unless you don't have any outstanding vulnerabilities except for the server you just pulled the network cable on, which is unlikely. If you have one, it's likely you have others most of the time. That's from what I've seen. So if you do get compromised through a web shell, it's very important you have a pen test to check for anything else that's externally facing that could be compromised by a web shell as well. Some endpoint software will let you push out a driver that basically stops TCP/IP. Like if there's isolation feature or a remediation feature, like certain software will let you do that, but don't just fire it off. If you see a web shell, you have to actually clear it with the people that are in charge of the server and get approvals, or you can wind up getting in trouble. Because remember, you'll cause business impact if you isolate a web server, especially without permission. A couple things I want to cover that you'll see both in the lab and in real life is one of them is search engines. Google and other search engines will crawl pages, which means they'll have to request it and get a copy of it in order for them to cache it. And a lot of these look at robots.txt to see what they're allowed to cache, but there's nothing really stopping anybody from caching stuff, even if they don't have permission via robots.txt. It's just that the more ethical search engines do that, but it's not to be expected.
Kevin, we have a question that came through. Can I pop it in?
Sure.
Yeah, we got a question from Tim. Have you seen any different behaviors from attackers using web shells on cloud hosted infrastructure versus on corporate owned infrastructure? Or are the behaviors and logging basically the same?
I haven't seen a lot of cloud, honestly, but they would be essentially the same. Yeah. And from what I've heard from a lot of people, they have more cloud experience than me. It's usually the same. There might be a couple more things to look at, but it's the same technology. It's just hosted on somebody else's machine, essentially.
Awesome, thanks.
Okay, so here's some other red herrings. These ones are more malicious in nature. A file scanner will just search for files. Like if they know that there is a program out there that has a default output file name of output.rar, some file scanners will go look for that file and try to get it in the hopes of scooping it up and getting some data that they weren't supposed to have. Or it might search for a known like e-commerce package or software they're familiar with that they can exploit. They'll simply request the file to see that it's there. A lot of these they're just profiling the software on there. So you'll see hundreds and hundreds and hundreds of different requests that all get 400 errors because none of the stuff you're looking for actually exists. What you would want to be worried about is the stuff that you get 200s on, especially if they follow up on it after. If they don't follow up on it after, you can probably assume that they got what they wanted out of it, or they'll be coming back. But if they hit 200 and then start picking at a file, that would be something to be more worried about, because it indicates that there's a human involved. Exploit scanners are even worse. They will shove exploit code into all different things, like the URI path. Sometimes they'll shove it in post variables. They'll shove code into forms that are on the page, just every single form on there, to see what happens. And these are the ones that'll tend to show up in the error logs. If somebody starts with an exploit scan and then goes and winds up doing more targeted stuff, like, for example, you see in the URI query that they're browsing through your file system. In other words, they have knowledge of the file system and they're looking through it. That would be something to be extremely worried about, because most web applications, or I would say like pretty much every legit web application, is not going to let you have that much insight into the file server of the file system of the web server. There's no reason to, and it presents a security risk. All right. Okay. So I gave a link here. I'll throw it into the chat as well. Just a place where you can look at web shells, the code for it. And I'm going to show you a couple of specific examples of web shells. So this is the most common one. It's the one-liner or an eval shell. Basically, these are one-shot command execution. So see how it says get here? What this means to PHP is it is looking for a get variable name command. And like I said before, this will show up in the URI path. So if I go back up here, like right here, this is get variables right here. So there's two get variables in this case. There's an action equals and a dir equals. In this case, there's one. It's just command. So in this case, there's get name command. I forget exactly what request is, but it's either get or post, I think. Well, it's either get or post. I don't know which. And then there's post, and that's what's not going to show up in the web logs. That's going to be in post variables. This is a very common web shell type of activity for China Chopper. Most of the time, China Chopper is implemented as just a eval shell, but you'll notice it's very busy. The red here is the requester, and on their end, they're basically running a client that knows how to specially formulate and send this encoded command in kind of its own self-contained package. And it always shows up like this with the Z1 equals, and there could be Z2 and stuff like that. If anyone's seen China Chopper before, you'll see this type of stuff over and over and over again. And this is typically used by attackers to do nation state type attacks. Blue is the response from the server. You can see in this case, it's a file listing. That's not the standard output of Windows for like a dir command. That was formatted by Chopper itself through the commands that it has. And Chopper is very client heavy. It is not server heavy. Remember, on the server level, it's going to look similar to this. There's no reason this wouldn't be good enough for Chopper. It's just what's on the client end that has a lot of code pre-written and kind of ad-lib to do certain functionality that's programmed into the client. If you ever see this, though, you should be extremely worried. Okay, so this one's what I would consider a script kiddie shell. When you see this type of thing, you're typically dealing with less serious attackers, just because they tend to favor these types of shells. They want the whole GUI, and a lot of it they didn't write themselves and they have no idea how it works. They're just copying it from somewhere. And the script kiddie shells tend to have a lot more functionality. You can see here, there's a bunch of random stuff in here. There's even, you can probably even do stuff like databases. So you can do stuff with databases on here. FTP, just more full featured than an eval shell. Here's another one. I've encountered this shell before. It's an encrypted shell. So there's a lot of shells that have passwords out there, but the password is just visible in the source code. So like you can just see it, and any defender that was able to retrieve the file could figure out what the password is because they'd have the source code. Unfortunately, someone came along someday and created this thing. It's called the PAS web shell, PAS web shell. I've seen it with some like Russian APT. They tend to favor this type of thing. just they tend to be on the more advanced end of things. And the way this works is basically there's a big encoded blob you see here, but in order for the requester to access the code that's encoded within that blob, they have to provide a password. And because of how it's implemented, you can't actually know what this shell does until you have the password, because it's basically just taking a password you enter in RC4, like RC4 or some other well-known crypto algorithm, decoding what's in there and then passing execution to it. So if you don't have the right password, you provide it, it's going to try to decode this huge buffer of data here. It's going to fail. And then when you command is passed to it, it's going to be gibberish. So the script will crash. So that's kind of probably one of the more advanced shells I've seen, just because I can't know what it does. I can read up what the paths shell capabilities are, but to actually get the contents of it, unless you have the password, it's pretty hard. Okay, so I was going to show you a couple quick things in our lab here before I show you the lab data you're going to be looking at. But this is one of our lab hosts. It's compromised by Webshells. Here's what the web directory looks like. These HTML pages here are the application itself. There's also a cat picture that's part of the application, but these ASPX files here are bad. They're web shells. I'll show you a couple of them. So here is a get shell that is a file browser. All I did was go to the file itself, and I'm just going to click through. This is the actual file system of our lab machine. So if I go into program data, notice here, this proves it's a get shell, because in the URI query section, I see a path that I would only really know if I had access to the system. And you might want to pay attention to this for the lab. It's pretty important. Something like this might be used in the lab, maybe. Okay, so, and if I go into inspect real quick and I start browsing around, I click Atomic Red Team here, and I go to network and I go to the GET request for it. We can already see in there that it's part of the URI query. I guess it didn't capture the request, but I guess this is fine. It shows where we're going, and it also shows my browser. So I'm going to try to execute command through it. Who am I? And that's who I am right here. IS app pool, default app pool. If I want to do host name, I get the host name. And you notice there's nothing up here. That's because this is a post shell. So if I go back to it and I do who am I? And I go to network, it's a little bit more complicated. Notice I put in who am I somewhere, right? I put it into here and I hit execute. It did not show up in my browser bar as you get, but it does show up here, obviously, because the commands have to get there somehow. The post variable with the name cmd exec is who am I, which is what I put in there. So if I put in who am I 2, which is not a real command, I get nothing back. I get an error message. But if I go to request and look at the post variables, I have who am I 2 here. So that's how that works. I'll give you this lab thing here in the chat. And the goal for this is you're going to want to find a bad actor as well as the get shell that they're using and the post shell. So you have answers here, challenge and questions. Start with questions. That's what you're going to want to find the answers to. You're going to want to find the bad IP, the name of the main get shell being used, the name of the main post shell being used. Look at the answers when you're done. And what's in challenge.txt here is the logs themselves, very similar to what you would get from a web server. It is lab data. Some of it was changed. So it's not a perfect replica, but it will definitely make you feel like you've done a web shell investigation if you go through the whole thing. So what I would do with this, actually, I'm getting ahead of myself here. So let's go back real quick. Here's some tips. You should be able to figure this out based on what's in this presentation, especially if you pay attention to what I say in here. You're going to want to use URI. There's URI encoding in this challenge. It mostly shows up in the URI query field. You can use CyberChef to decode it. So I'll quickly find you an example of URI encoding in here. Let's say this right here. I want to take this and do URL decode. See, so this is how you URL decode stuff. And that's what your URL encoding looks like. It'll make it look nice like that. What else do we have here? I like to use Excel to analyze logs, but if you don't have that, you can use Google Sheets, especially since this is lab data. Pay attention to the URI path to know what files are being accessed on the server. URI query to know what the person that's accessing the script on the web server is trying to do. If it's a GET request, if it's a post request, you're basically out of luck. Status code, which will tell you if it was likely successful or not, and time taken to a lesser extent. If time taken fluctuates, it's more likely that a human is involved if the fluctuation is on the same script around the same time. Definitely look out for the telltale signs of web shells on slide 13 and watch out for red herrings on slide 17 and 18. Both of those should be in there. So you'll get an idea of what those look like. So hopefully you're better prepared next time when you encounter a real web shell on what to look for.
Thank you so much for everybody that joined this session. These happen every 2 weeks. If this is your first time joining, welcome. I hope you enjoyed this session. In 2 weeks, we're going to have a session following up on our Detection Engineering 101 kind of series. We're going to follow up their first episode that we ever did and get into actually building the detection. So join us. If you register, you only have to register once, so get the bi-weekly invite. But thanks so much for attending, everybody, and have a great rest of your day.